People need to understand that when you're doing something on your phone, when you're using your computer, behind that, there are large data center needs. People don't maybe see how they impact the energy demand by doing very small things.
The digital revolution is reshaping our world, and nowhere is that more visible than in the rise of AI. But behind every chatbot, algorithm and smart device sits an invisible network of data centers consuming vast amounts of power and water. So, can technology fix the problems it's helping to create? I'm Mike Scott, and this is the Roads to Carbon Neutral podcast. Data centers use nearly 1.5% of the world's electricity in 2024, according to the International Energy Agency. And that demand could double within the decade as AI continues to grow through every part of our lives. The real test is whether AI can save as much energy as it spends. But let's start by taking a step back to understand why AI needs all this power in the first place. To find out, I spoke to Professor Mahmoud Kandemir from Penn State University. He researches the hardware behind AI, in other words, how our chips and data centers handle the huge amounts of processing these systems demand.
For training, you have large amounts of data, you go over it multiple times, and you determine after that the values of a large number of parameters. Each step, actually, what you do is a kind of a relentless number of matrix multiplications. And the matrix multiplication is a costly computation that makes training very, very energy demanding. Not all trainings are successful, unfortunately. Some trainings fail. So that also increases the cost.
And all that computing, all this data, has to live somewhere, inside vast data centers filled with racks of servers that run around the clock. But AI isn't just an energy challenge, it's also helping us tackle some of the world's biggest environmental problems. It can optimize industrial systems, make transport more efficient, reduce waste, and even help scientists model climate patterns more accurately.
Most digital twin algorithms that are proposed today and will be proposed in the near future will be basically powered with AI. And that's another way AI is going to help us and the environment. And the problem is that we basically want better algorithms, more sophisticated ones with the higher accuracies, better prediction rates, and so on and so forth. And consequently, we need more resources to do that. We need AI literacy. And we need to actually teach people to use it in a more responsible fashion.
People need to understand that when you're doing something on your phone, when you're using your computer, behind that, there are large data center needs. People don't maybe see how they impact the energy demand by doing very small things. So we can look at the data centers and tell them or blame them for what they're doing. But I think that the truth is that we are all consuming and we are all pushing them to demand to produce more. So we need to work with them, and they need also to be more transparent so that we can make the right choices in the way we're consuming data, the way we're consuming their services.
That awareness is starting to shape how the industry itself operates. David Brule from TotalEnergies works directly with some of the world's leading data center and electronics companies, helping to power the massive facilities that keep the digital world running. I asked him how the energy sector is adapting to meet this surge in demand.
There is a growing demand for energy linked to data centers and AI. The data center operators need to work with the grid operators. They need to work also with the utilities to ensure that they've got a stable load that will be generated. And to do so, they work with us to make sure that we're providing new capacities of renewable sets, but also flexible sets where they are installing new data centers, so that the place where they are located will keep on benefiting from a stable load, stable supply. It also puts pressure on the grid. But at the same moment, AI, data centers, hyperscalers, collocations, they are heavily committed on decarbonation. They've taken large commitments. They are large adopters of renewable energies, and they are pushing the other industries to move. But they also help the other industries and their supply chain in their decarbonation.
If you want to be an efficient player in the field of energy, you need to be good in data and AI.
David's world is all about building the more sustainable energy solutions that power the cloud. But within those systems, there's another story. how digital tools and artificial intelligence are helping the energy industry itself.
My name is Michel Lutz. I'm Chief Data Officer in TotalEnergies, so in charge of the major transformation programs around data and AI. The interesting thing is that really we are at the crossroads of energy and AI because we need better energy to supply the AI data center. On the other hand, AI will help us to produce better energy, either oil and gas or electricity and renewable. And I think that's a very exciting challenge of today.
Michel, do you feel as though the benefits of AI can outweigh the impacts of the technology?
That's a good question. To be honest, if we invest in AI, it means that we really think there will be positive benefits. And so it will be for the better of energy in the future. It's also important to have in mind the issue of energy for AI mainly come from generative AI, which is only one category of AI. But then we can fix a lot of other issues with the non-generative AI, which are much more energy efficient.
So, AI is already helping make our energy systems smarter and more efficient, but there's still more we can do to cut the carbon impact of the data centers behind it.
Storing data is a problem, right? And it basically can consume a lot of space, a lot of energy, and so on and so forth. And you can have actually more energy efficient storage. Again, researchers are working on that.
Professor Kandemir says one of the biggest energy costs in AI isn't the computing itself, it's moving all that data back and forth between storage and processors. Edge computing flips that model. Instead of sending information long distances to be processed in a huge data center, you process it locally, right where it's generated, cutting down on the energy used for transmission. And now researchers are thinking even bigger, moving computation itself to wherever renewable power is most available.
Renewable energy, in theory, on paper, is a wonderful thing. The problem is that renewable energy is not 24/7. If you rely on the sun, you don't always have sunlight. If you rely on the wind, sometimes it doesn't blow. So basically, you need to adapt. Adapt meaning that if you are really going to use renewable energy, and if you are really intending to use it most of the time, you need to be able to shift your computation from place to place. And actually, that can be done because computation is a commodity that is entirely movable. Actually, that's a very good advantage. You cannot move a car from here to some other place very easily. But computation is not like that. My expectation is that if you look at the next decade, I think these big vendors, cloud vendors, are going to accommodate more and more renewable energy sources. And that actually might change the way that we do the computation because our computation is not going to be very stationary. It's going to move around looking for renewable energy source.
The relationship between AI and energy is only just beginning. The same technologies that are driving up demand for power can also help us to use it more intelligently. From greener grids to smarter algorithms, the future of AI will depend on how wisely we use the energy behind it. Thank you to our guests, Mahmoud Kandemir, David Brulé and Michel Lutz. For more from the series, visit roadstocarbonneutral.com. And to discover more on TotalEnergies' energy transition activities, visit totalenergies.com/energy-transition.